Next concepts are project management. Application 2.7. Project management. What is meant by a project, sir? Construction of flyovers, construction of multi-storied buildings, construction of an office complex. All these are coming under the heading of a project. So it consists of certain activities which we have to complete. Therefore, we can define a project as a network of some interrelated activities. A project is a network of some interrelated activities which are connected in a logical and sequential manner. Look at the definition one more time, sir. A project is a network of some interrelated activities which are connected in a logical and sequential manner. As a project manager, you are interested to know what will be the completion time of the given project. So for completion of this project, each and every activity we have to complete. Each activity will take how many times? Each activity will take how many number of days? And after that, if any activity can be delayed, for how many days I can delay this one without delaying the project completion time? These type of various questions. These are the various types of questions we have to answer when we are dealing with this project management. Okay, sir. One more time, look at the definition. A project is a network of some interrelated activities which we are connecting in a logical and sequential manner. Next, as a project manager, what type of information you want to gather from the network? First question of mine is, how many days this project will take for completion? What are the resources required? Because when I am completing a project means huge capital is involved. If I want to complete this project, each activity can be completed in how many number of days? Fine, sir. If any activity can be delayed, for how many days it can be delayed without delaying the project completion time? These are the various questions which I can answer when I am studying this one. That is project management. Okay. So, look at another definition of this. An activity is a small part of a network. Is a small part of a network which will take time for completion and consume some resources. Labor is required, machines are involved for construction. Therefore, each activity will take how many number of days? That is what an activity stands for. An activity in a network can be denoted by an arrow diagram. An an activity in a network can be denoted by an arrow diagram. Every activity in a network has two nodes. Look at this. This is an activity. 4 days. So in a network, an activity is represented with an arrow diagram, and it is having two nodes. From which this activity is starting. This is called initial node or tail node. Here you are completing this activity. So this is called a terminal node or head node. Terminal node. Okay, sir. Look at these points one more time. A project is a network of some interrelated activities which are connected in a logical and sequential manner. Second point is, an activity is a small part of a network which will take time for completion and consume resources. An activity in a network can be denoted by an arrow diagram. Every activity in a network has two nodes. First one is called initial node, the next one is called terminal node. At the initial node we will start construction of this activity, and by the time when we reach to the head node, its completion is over, its construction is over. So head node will represent by what time you are reaching to this particular node. Tail node will tell you at what time you are starting this activity. Every network, you can say project, has only one initial node, and one terminal node. Only one initial node and one terminal node. Every network has only one initial node and one terminal node. Next point. A project or a network is always started with independent activities or activities. Independent activity or activities. A project is always started with independent activity or activities. Okay, sir. For example, activity A, activity B is dependent on A, whereas C is dependent on B. What is the meaning of this one, sir? Activity B cannot be started before completion of A, and C cannot be started before completion of C, before completion of B. So A is not dependent on any activity. So as and when this project is allotted to us, we can start with A. As and when A is completed, you can start B. As and when B is completed, you can start with C. So this can be taken as ABC in this manner. Now let us take another example with the two independent activities. Activity C is dependent on A and D is dependent on B, and D is dependent on B. Okay, sir. Here A and B, they are not at all dependent on any other activities. Therefore, they are called independent activities. You can start activities simultaneously. This is activity A and this is activity B. As activity A is over, you can start activity C. As and when activity B is over, you can start activity D. When all these 4 activities are completed, this project is over. This project is over. This way, first, before any calculations are taking place, you have to construct a network diagram. Once a network diagram is constructed, we can calculate earliest starting time of each activity, earliest finishing time of each activity, latest starting time and also latest finishing times. Further, what additional information you will get, sir? Suppose you want to delay the completion time of any particular activity. So for how many number of days this activity can be delayed without delaying the project completion time? This type of information you will get from this network diagrams. Okay. So look at the definition what is given in our material. Project management is literally an investment of resources to produce goods and services for consumption. Or you can say project management is planning, organizing and monitoring and controlling of all aspects of a project and the motivation of all involved to achieve the project objectives of safety and within a defined time, cost and performance. Anyway, the definition is given, but it is simply a network should be completed. A project can be completed within a stipulated time. And as a project manager, you have to calculate earliest timings and latest timings of each activities. So first, what are the techniques for project management, sir? It is given project execution planning techniques. Project execution planning techniques, project selection techniques, project scheduling and coordinating techniques, and project monitoring and progressing techniques. It is given in our study material which may be asked for theoretical questions, sir. So before I am discussing these theoretical questions, let me introduce some problems of construction of networks and drawing of these networks and calculations involved. Okay, sir? You please take up these things, then I will go for some problems. Now first one is network based techniques. First one is network based techniques by PERT and CPM. Network based scheduling techniques. Under this A, network based scheduling techniques. Network based scheduling techniques. Under this first one is CPM, critical path method. Second one is PERT, program evaluation review technique, program evaluation review technique. Third one is resource allocation, and multi-project scheduling. Next one is graphical evaluation technique. Graphical evaluation and review technique. Next one is multi-operation scheduling. Multi-operation scheduling technique. MOS operations scheduling system. This is next critical operating production. Critical operating production. Critical operating production allocation control. COPAC. Next we have least cost scheduling. Least cost scheduling. Eighth one is manpower allocation procedure. Manpower allocation procedure. MAP. And resource planning and scheduling method. Resource planning, scheduling method. Resource planning and scheduling method, RPSM. These are the 8 techniques we are having, which are called network based scheduling techniques. It is a 2 marks question, sir. It is a 2 marks theoretical question. What are the network based scheduling techniques in a project management? So you have to write a critical path method, program evaluation review technique, resource allocation and multi-project scheduling. Resource allocation stands for what? How much labor should be allotted for completion of each activity? And when multi-projects are simultaneously involved, means when you are constructing 2 projects at a time, and when there is a scarcity of labor, how can we adjust that? Graphical evaluation and review technique, multi-operation scheduling system, critical operating production allocation control, least cost scheduling, manpower allocation procedure, resource planning and scheduling methods. These are the various network based scheduling techniques we are having. Out of this, CPM and PERT are most popular techniques we are using for network based scheduling. So this project management concept I am introducing with the help of CPM techniques first. Okay, sir. Before I am taking any question, sir, you take up these things. Okay. Now first let us take critical path method. Critical path method. Let's have a problem here. Sir, this concept we had in final. That time operation management was in CMA final. So I have the suggested answers of those. Most of the problems I am solving from those suggested answers, because in your study material only 2-3 problems are given. Okay, sir, for your convenience I am solving all those problems also. Look at the question. Following are the various activities. Question number 1. Following are the various activities involved in a project. Now this is duration. Activities are A, B, C, D, E, F, G, H, preceded by dash, 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 B, comma, D, and C, comma, E. Duration is 3, 6, 2, 4, 2, 7, 4, 3. This way it is given. Okay, sir. Look at the problem. How many activities we have? 1, 2, 3, 4, 5, 6, 7, 8 activities we are having. So first row will represent number of activities this project is having. Next, second row will tell you what's our starting of these activities are dependent on completion time of which of the activities. So first row activities are dependent on some other activities. So second row will tell you these activities are dependent on whom. Third row is duration, sir. Third row is duration. Means each activity will take how many number of days. This is the information given. Based on this information, you have to draw a network. Next, identify the critical path activities and also calculate project duration. Okay. So one after another, to answer these questions, let me draw the network first. When I am drawing a network, what are the things I have to remember? First, a network is always started with independent activities. You have to start a network with independent activities, sir. What is an independent activity? Independent activities are those which are not dependent on anyone. Here, A, B, C, these 3 activities are not dependent on anyone. So I can start the network with these 3 activities. Look at the network. These are the 3 activities we have. As and when activity A is completed, I can start DEF, activity A, B, C I can start simultaneously. So these are the three activities we are having. As and when activity A is over, you can start the activity D, activity E and activity F. Therefore, D, activity E, activity F. I'll take C. This is F. Fine, sir. Next, when I want to start the activity G, first we have to complete B and D. Now, sir, for any activity, if I have more than one predecessor, if I have more than one predecessor, then what I have to do? First, these two activities should be joined at one node. So when you are drawing two activities, when you are joining two activities, remember one thing when you are at the time of drawing a network. No two activities in a network can have same initial and terminal nodes. One more time I am repeating this point, sir. When I am constructing a network or when I am drawing a network diagram, sometimes two activities or more than two activities I have to join at one place. Clear? When I am joining two or more than two activities at one particular node, remember, no two activities can have same initial and terminal nodes. On which area I have to concentrate, sir? No two activities in a network can have same initial and terminal nodes. Okay. So B is having this as the initial node, whereas D is having this as the initial node. Therefore, I can join these two activities. Therefore, joining B and D here, B and D activities are joined at one place. In the same manner for H, first you have to join C and E. So joining C and E. Next, B and D, when they joined together, that is, when B and D, these two activities are merged at one node, from this node, you take activity G. Next, when C and E are joined at one node, from this you take H. You take the activity H. And after F, there is no other activity to perform. Join this one at the last node. Why I am merging all the activities at this particular node, sir? Because every network has only one initial node and one terminal node. Every network has one initial node and one terminal node. Therefore, you have to join these two. At this node. And after F, there is no other activity to perform. F also joined here. This way, first a network is drawn. When a network is drawn in this manner, then you have to go for giving numbers to these nodes. You have to give numbers to these nodes. Okay, sir. Look at this. For giving the numbers, you have to move from left hand side to right hand side. When you are giving numbers to these nodes, you have to move from left hand side to right hand side. Okay, first point. Second point is the numbers which are given to the head node are greater than the numbers given to their tail nodes. Once again, I am repeating this point, sir. When I am giving numbers to various nodes which I have in a network, I have to move from left hand side to right hand side. Clear? Second point. The number given to the head node is always greater than the number given to the head node is greater than the number given to the tail node. So 1 is given to this number, 1 is given to this number. Now sir, for this activity A, this is the head node. So number 2 is given here. After this, 3 activities are coming from this particular node. For these 2 activities, this is the head node. So number 3 is given here. For these 2 activities, this is number 4 given here. The head node number here is greater than the numbers you have already given to the tail node. Next, this is 5. This is 5. This way, how many nodes we have? 5 nodes we have. Now, activity A will take how many days, sir? Activity A will take 3 days. Activity B will take how many days? 6 days. Activity C will take how many days? 2 days. Activity D will take 4 days. Activity E will take 2 days. Activity F will take 7 days. Activity G will take 4 days. Activity H will take 3 days. Activity H will take 3 days. This way you have to represent the given information on a network diagram. Clear, sir? Next, what I am doing, sir? I am calculating the earliest timings. I am calculating the earliest timings. Earliest timings means each activity can be started earliest by what time and it can be finished earliest by what time. For that, I am moving from left hand side to right hand side. It means starting from node number 1, you have to move towards the last node 5. As a rule, you take earliest time of node 1 is 0. Earliest time of node 1 is 0. Earliest finishing time of an activity is equal to earliest starting time plus duration. Earliest finishing time of an activity is equal to earliest starting time of that activity plus its duration. You have to add. Now look at this, sir. 0 at the time I can start activity B, because on the very first day 3 activities you started simultaneously. Therefore 0 be the starting time of all these 3 activities. 0 be the starting time of all these 3 activities. Activity B will take how many days, sir? 6 days. 0 plus 6, 6. So I can start this activity on 0th day and I can complete it on the 6th day. Now here activity A, I am starting on the 0th day. It will take 3 days only, sir. I can complete it on the 3rd day. Next, activity C also, I am starting on the 0th day. 2 days it will take. Therefore 2. 2 days it will take. End of the 2nd day, this is over. Now, sir, earliest timing of 2 is equal to 3 days. On the 3rd day, where I am standing in a network, sir, at node number 3. At node number 2, I am standing on the 3rd day. What I am doing on the 3rd day? Activity D, activity F and activity E. 3 activities are started simultaneously. Activity D, activity E and activity F. These 3 activities are started simultaneously. So for these 3 activities, for 3 is the starting time. 3 is the starting time. Okay. Activity D will take how many days? 4 days it will take. Activity D will take 4 days. So 3rd day you are starting plus 4. 7th day you are completing this activity, sir. third day you are starting and seventh day you are completing this, because this activity will take only 4 days. Next, activity F can be started on the third day. It can be completed on the 10th day. It can be completed on the 10th day. Activity E will take 3 days. Activity E can be started on the third day and it will take 2 days only. It can be completed on the 5th day. It can be completed on the 5th day. Now look at this, sir. Activity node number 3. Earliest timing of node 3. Look at this, sir. Activity G cannot be started before completing B and D. Activity G cannot be started before completion of B and D. On which day you are completing activity B, sir? On the 6th day you are completing activity B. On the 6th day you are completing activity B. Whereas on the 7th day you are completing activity D. Therefore, G cannot be started before 7th day. G cannot be started before 7th day. Therefore, earliest I have to reach to this node on the 7th day. Or even if I reach it on the 7th day, no problem. 7th day, I am starting activity G. 7th day, I am starting activity G. How many days it will take, sir? 4 days. So 7 plus 4, 11. 11th day I can complete. Now come to the node number 4, sir. Come to the node number 4. Earliest timing of 4. Here I want to know on which date I have to reach this particular node, so that this activity H can be started at its earliest time. Activity E, you are completing on the 5th day. Activity C, you are completing on the 2nd day. One more time. Activity E, you are completing on the 5th day, sir. Whereas activity C, you are completing on the 2nd day. Therefore, activity H cannot be started before 5th day. Activity H cannot be started before 5th day. Why? Because H starting time is dependent on the completion time of E and C. So, this is 5. 5th day, you are at node number 4. On the 5th day, what you are doing? You started activity H. For this activity H, 5 is the starting day. 3 days it will take. 8 is the completion time. 8 is the completion time. Okay, sir. Now I want to know on which day I am reaching here. Sir, a project is completed only when all the activities are completed. Activity G you are completing on the 11th day. Activity F you are completing on the 10th day. Activity H you are completing on the 8th day. Maximum of these 3, 11. So earliest time of 5 is equal to 11 days. Earliest time of 5 is equal to 11 days. Okay. Look at this one more time. 0th day, you are at node number 1. 0th day, you are at node number 1. And on the 11th day, you are at node number 5. So, from the 0th node, initial node to 11th node, that is 5th node, you traveled from this first node to the last node in how many days? 11 days. So the project is completed in 11 days. The project is completed in 11 days. 11th day, in 11 days means on the 11th day you are completing, maybe at the beginning or middle of the day or end of the day, sir. This way, before a construction work actually starts, production manager will do for calculations. Production manager will go for calculations. Through these calculations, he estimated that the project can be completed in 11 days. the project can be completed in 11 days. Okay, sir. But in real time, that is in real life, it is not possible sometimes to complete all the activities at their earliest timings. At the same time, if it is not possible to start it at earliest time, then latest on which day I can start and latest on which day I can complete without delaying the project completion time. Without delaying the project completion time. For that, one more calculation is required. What is that, sir? Latest timings. Latest timings. Look at this. Latest. I have to complete this project on the 11th day. Latest. I have to complete this project on the 11th day. For that, there are 3 activities which are merging here, sir. There are 3 activities which are merging here. So these 3 activities I have to complete on the 11th day. Then only I can say it can be completed on the 11th day. So for these 3 activities, 11 is the finishing time. 11 is the finishing time, latest. Now, latest starting time of an activity. Latest starting time of an activity is equal to latest finishing time minus duration. Latest starting time is equal to latest finishing time minus duration. So 11 minus 3, 8. To finish it at latest on the 11th day means I have to start latest by 8th day. Here 11 minus 7, 4. 11 minus 4, 7. So for activity H, for activity F and for activity G, earliest and latest timings are calculated. Above the arrow earliest timings, these are latest starting and latest finishing. Now sir, look at this. To start this activity on the 7th day, you have to reach this particular node on the 7th day. Then only its succeeding activity can be started on the 7th day. To reach this particular node on the 7th day means 2 activities are merging here. 2 activities are merging. These 2 I have to complete on the 7th day. These 2 I have to complete on the 7th day. So this is 7 minus 6, 1. 7 minus 4 means 3. To reach here on the 7th day, latest it should be started on the 3rd day, whereas it can be started even on the 1st day also. Next, sir, it is a bursting node. At node number 2, how many activities are coming? 3 activities. To calculate the latest time here, first, let me calculate the latest timings of activity E. For this, activity H, you have to complete latest by 11th day. So you have to start it on the 8th day. To start this on the 8th day means I have to reach this particular node on the 8th day. To start this on the 8th day, I have to reach this particular node 4 on the 8th day. At node number 4, how many activities are merging? E and C, 2 activities are merging. So for these 2, 8 is the finishing time. Activity E will take 2 days, 8 minus 2, 6. Activity C will take 2 days, 8 minus 2, 6. Now, for D, F and E, earliest and latest both are available. Look at this. Activity D, you have to start latest on the 3rd day. Activity F, latest can be started on the 4th day. Activity E, latest can be started even on the 6th day. Out of these 3, what is the minimum? 3 is the minimum. It means earliest you have to start this on 3rd day. So you have to reach node number 2 on the 3rd day. If I reach this node number 2 on the 3rd day, then only D can be started latest by 3rd day. Otherwise, it is not possible. Therefore, latest timing of 2 is 3. This is 3 minus 3, 0. 3 minus 3, 0. Now, sir, 106. What is the meaning of this? Activity B, latest can be started on the 1st day, on day number 1, end of the day number 1. It is 0th day only, same day you have to start. It can be started even on the 6th day. Minimum of these 3 is 0. Latest timing of 1 is 0. This way, earliest timings and latest timings are calculated. After that, I want to calculate length of the project, sir. For this, path and length. Path and length. Look at this. How many paths it is having? 1, 3, 3, 5. This way, I can reach to node number 5 from 1 to 3 and 3 to 5. 1 to 3, it will take 6 days. And 3 to 5, it will take 4. So 10 days. Next, 1 to 2, 3, 3, 5. 1, 2 will take 3 days. 2, 3 will take 4 days. And it will take 4. 4 plus 4, 8 plus 3, 11 days. Next, 1 to 2, 5. 1 to 2, 5. 1, 2 will take 3 days. 2, 5 will take 7 days. So this path will take 10 days. Next, 1, 2, 2, 4. 1, 2, 2, 4, 4, 5. 1, 2, 2, 4, 4, 5. 1, 2 will take 3 days. 2, 4 will take 2 days. And 4, 5 will take 3 days. 3 plus 3, 6 plus 2, 8 days. Now finally 1, 4, 5. 1, 4, 5. 1, 4, it will take 2 days. 4, 5, it will take 3 days. 1, 4 will take 2 days. And 4, 5 will take 3 days. 5 days. So how many paths this network is having? 1, 2, 3, 4, 5 paths it is having. Out of these 5 paths, sir, which path is having longest duration? 11 days is the longest duration. So that path is 1, 2, 3, 5. 1, 2, 2, 3, 3, 5. So the path which is having longest duration, the path which is having longest duration is called critical path. Critical path. The path which is having longest duration is called a critical path. And one more important observation for critical path activities is, look at this, sir. For critical path activities, earliest timings and latest timings are coinciding with each other. Earliest timings and latest timings are coinciding with each other. It means each of these activities we have to start at their earliest timings and we have to complete them at their earliest timings. Suppose starting time or completion time of any of these activities are delayed, then the project completion time is also delayed for the same number of days. Also the project completion time is also delayed for the same number of days. So that much of importance a critical path is having in a network. Okay, sir. This is what he asked in this question. That is what we calculated. Note down the things, sir. First problem will put you in confusion because most of you are learning this particular concept first time. So you may feel it tough. Don't worry. I'll solve 5 to 6 problems minimum to make it very clear. Once it is clear, then only I'll move to further. Okay, sir. So first problem will give some confusion or create some tension to everyone. Okay, sir. Note down the solution.